Hi guys, so today we'll be solving Leetcode 2251, number of flowers in full bloom. So you're given an integers array flowers and array people. Array flowers represent okay, it is represent by start and end, means that the ith flower will be in full bloom from start to end. So basically this thing means that there's a flower in full bloom from 1 to 6, there's a flower in full bloom from 3 to 7. Okay, so you're also given a zero index integer array of people, where people at index I is the time that the ith person will arrive to see the flowers. So your task is to return an integer array of size n, where answer at index I is a number of flowers that are in full bloom when the ith person arrives. So basically, this person arrived at a time of 2, right? So it will be in range of this interval, right? This interval and this interval only, right? So basically he will see one flower in full bloom. For this guy, he will arrive at time 3. He will be at in this interval. He will be in this interval, which means he can see 2 flowers in full bloom, right? And vice versa. So basically this question is pretty much like this one, right? Minimum interval to include each query. Basically we will sort the queries and then sort the intervals, and then we just lazily push the interval with the start smaller or equal to the queries into the min heap, right? But there's a small difference here. We need to return the length of the min heap, right? So in order to do that, we need to pop out the flowers that is dried out. What do I mean by dried out? For this guy, right, we coming to this guy, we have already have these 2 guys in our min heap, right? Basically we need to pop this guy out. Why? Because by the time that this guy come to see the flower, this guy has already been dried out, right? So we are left with this guy in the min heap, and we return 1, right? So that's what I mean by dried out. Okay, so we can maintain a min heap for each of the people, right? We will push in the interval with the start smaller or equal to the time that they arrived, and after that, when we will lazily pop out the flowers that has been dried out. And we can do that by basically we push in, rather than push in the start and the end of the flowers, we will push in the end and the start of the flower. So the min heap will sort these intervals by the end first, right? Basically, like, the flowers that has been dried out will be pushed to the top of the heap, and we can just check if the top of the heap is a flower that has been dried out, and we just keep popping it out, right? So I hope you understand the intuition behind it. So now we will go to the implementation part. We will have to sort the flowers, right? We will have to sort people. We need to keep the index of the people array, right? Because we want to return the result based on that original order. So this is what we will do. Now we have a list of tuple contain the index and also the value, right? And now we need to sort this list based on the value. Which means x at index 1, right? Now we have to initialize our result array, which basically will be 0 and then length of people, right? We need to initialize our min heap. And then for start, for time arrived in people, right? We need to check while I is smaller than length flowers and flowers I 0, which means the start of the interval is smaller or equal to time arrived. And then we need to check if the n is also larger or equal to the time that this person arrived, right? If flowers I1 is larger or equal to time arrived, which means this flower can be seen by these people by the time this guy arrived, right? So we push it to min heap, and what we are going to push to the min heap is the n first and the right and the start of the interval, right? Okay, now here's an important part. We need to pop out flowers that have been dried out, right? So why min heap and min heap 0? What is the n? The flowers that has been dried out is the flower with the n, right? With the n smaller than the current time arrived. So the n is actually 0. Why? We push the n as the first value in our to the min heap, right? Is smaller than time arrived. We hip hop, right? Okay, sorry, this is actually index and then time arrived, right? Now we can just do whatever is inside the min heap right now. This person can see that flowers, right? Now the min heap contains all of the qualified candidate. We can just do result index is equal to length min heap. Now we just return result. oh, I'm sorry, if we need to increment the index, the pointer, right? I think that's basically it. Oh, I'm sorry. Okay, submit it. Okay, also here is, if you want to make the code more neat, you can actually delete this guy, right? Why? Because here I will check if in our current you can say query, right? In our current query, if there's anything that's actually satisfy the start condition but not satisfy the end condition, I will not push it to the min heap. But actually these two lines here actually take care of it, right? And you can do this, you can just push it to the min heap, and then this guy will take care of it, and the code will be a little bit smoother, cleaner, right? Okay, so the time complexity is actually complexity. We need to sort the flowers. Let's say it's like the length is n, right? So it's n log n. We need to sort people, which means m log m. We need to heap push and heap pop inside for loop side m, right? That's m. Heap push and heap pop, each of these is operate on a potential heap size n, right? So basically n log n. N log n, that's for heap push, and another n log n for heap pop, so that's mean 2n log n. So that's basically 3n log n plus m log m plus 1, right? So we can actually reduce this. We can reduce this to n log n and m log m. And the space complexity, we need to maintain a min heap size n. And then this guy size m, right? This people guy. Okay. Also resolve size m, that's n plus 2m, which means n plus m. Okay, I hope it makes sense to you guys. See you guys in next videos.